Hey guys, this is Mike. I am going to shoot a real short video for you because I wanted to show you the mechanical interlocks of a reversing magnetic motor starter. Now the one that you're going to work with on the Amatrol trainer does not, it's all encased and you can't see the mechanical workings of the mechanical interlock. So that's why I'm shooting this video. This is a Seimens magnetic reversing motor starter. I think I held it up as a demo there in the video, but I'm going to dial in and I want to really get an up close and a tightened up image of these mechanical interlocks. But first of all, it's a reversing motor starter, and you're going to have two sides for one side for the forward and one side for the reversing. Okay, and here are the connection points for your coil for the forward side, and likewise there are two over here for the reversing side. Okay, they also have normally open auxiliary contacts, and this is the input side, the upstream side of that contact. You can't see the outgoing side. It's up under here where my finger's at. And then so that's for the forward side. Well, the reversing side also has the exact same thing. It has a set of normally open contacts, and again, these are the auxiliary contacts, and they can be used for couple of different purposes, but most often they're used for seal-in circuits or three-wire control circuits that you've worked with already in the basic control lab. Each side also has a normally closed set of electrical interlock contacts. Okay, this is the side for the forward side, and this is the side for the reverse side. Okay, so they're identical, you know, as far as their function and everything. One side is forward and one side is reverse. And I think I showed you in the video that you've got L1 tied over here to L3, L2 stays with L2, and L3 goes to L1. So our feeding power would come right here where my fingers are at. Then we would jumper it over, and when we jumper it, that's where we're doing the swapping of the two leads to make it reverse. Also, you'll notice down here, this is the overload relay, and these two sides of the contactor share the overloads, because you're only going to be running in one direction at one time anyway, and you can monitor it in forward or reverse as far as the overloads. Okay, and then down here on the side are the normally closed overload relay contacts that go into the control circuit. Okay, so I just want to kind of talk to you about that, and then the three-phase will feed straight through here all the way out to the overloads. On the reverse side, it feeds in here, and you'll notice three wires come over here, and they transfer the outgoing power from the contactor part and pass it through the overloads and then out to the motor. So anyway, but what I'm really wanting to talk to you about today is I'm going to try to dial in here, and I want to show you these mechanical interlocks. Okay, like I said, they're hard to see, so I'm going to dial it in here as tight as I can get without going out of focus. Okay, I think we should be able to do it there. And you can't see this on the Allen Bradley, but I'm going to simulate energizing the coil. Okay, so when I energize the coil, what's going to happen, you'll notice here, what I want you to pay attention to in particular is this right here, these little pieces right here. One on the forward side and one on the reversing side. Okay, so what I want to show you here is that if the forward side gets energized, and I'm simulating things by pushing the armature in, okay, but I want you to notice that the white tab over there will come into the path. You can kind of see that right there. Okay, what it does is it comes into the path of the one on the right hand side for the reversing. So now if I'm trying to reverse, it's physically blocking it out. Okay, now if the forward is not energized and I want to reverse, it can then pull in. So basically what happens, what this is doing is, and this one now is keeping the forward side from coming in. And basically what it's doing is, if our electrical interlocks were to fail for some reason, okay, and we push the forward and reverse button at the same time, both coils would energize. This is in the event that the electrical interlock contacts here were to fail, and we did actually energize the coils. One of them would come in first and physically block the other ones out, so that the three-phase cannot become connected with one another. If you had both of these, if you were able to energize these both at the same time, it would cause a phase-to-phase short. But what's happening here is we're protected in two different ways. Okay, back out just a little bit. We're protected in two different ways. We've got the electrical interlocks right here that keep us from energizing a coil. For example, if the forward coil is energized, we're going to have this normally closed set of contacts in the path of that coil, and that way if the forward coil is energized, it's going to block the path for this reverse coil being energized, okay, and vice versa. We went over this in the lecture. But if they were to fail for some reason, if we were able to pull them in at the same time, one of them would step out in front of the other, and it would block. You can see that one trying to move into the path of the other one's got it blocked out. And if the reverse one were to come in energized first, it's blocking out the forward one. So that's how the electrical and mechanical interlocks work. But I wanted to dial this in a little bit tighter for you so that you could see how the mechanical interlocks work. Again, this is a Seimens starter. It's a little bit more open as opposed to the Allen Bradley, which is encased, and you can't really break it apart and look at it. But I hope this helps. I said I'd make this little video, so there it is. And if you got any questions or you want to see this in person in the lab, give me a shout, find me, and we'll go look at it together.